Hello and welcome. This video I will talk about transformations. These include translations, reflections, rotations, and dilations. I will have chapters on the video set so you can click through to which type of transformation you need help with. But first, let's talk about isometries. An isometry is a transformation that does not change shape or size. Translations, reflections, and rotations are all isometries, but dilations aren't. Now on to translations. A translation is a transformation where all the points in a figure move the same distance in the same direction. Now, let's draw a coordinate plane and place a point on a random place. For this demonstration, I will place the point on the coordinates 3x, 2y, and call it A. The most simple problem you will be given will look something like this. This is called the rule. To use the rule, you simply need to use the instructions given. If you add 3 to 3, the new x position will be 6. Then if you subtract 2 from 4, you'll get negative 2 on the y position. One thing to take note of is that the old point of 3x 2y is called the pre-image, while the new value of 6x negative 2y is called the image. Another thing to notice is that the new point is called a prime. It is written with an apostrophe after the letter. Now, not every problem will just give you the translation rule. You'll have to find it out. Here, I will draw a random shape and its image. To find out the rule, you need to look at one point and its prime, and figure out what coordinates are on. Now let's choose B and B prime. B is on 4x 2y, while B prime is on negative 2x 4y. I'll give you a couple seconds to see if you can find the rule on your own. If you got this, that is correct. Now to find that, you could either count the graph to find the rule, or the better method, you could subtract one point in the image to that of the pre-image to get the answer. And because a translation means the transformation is equal everywhere, you'll only ever need to pay attention to one point and its prime. Next are reflections. A reflection is a type of transformation that flips a figure along a line of reflection, so that the image and pre-image are the same distance away from the line of reflection. I'll place a line segment on the graph. Point A is on 3x 2y, and point B is on 5x 5y. The simplest problem you'll be given is this. Graph line segment AB over the x-axis. Here, the x-axis is the line of reflection. Imagine it as a mirror we use to reflect. Because we reflect on the x-axis, the x-coordinate of each point won't change, but the y-coordinate will swap its symbol. This works the same way if you reflect across the y-axis, but vice versa, with x swapping its symbol and y staying the same. Sometimes you may see this. Reflect point A over y equals x. This is essentially saying the line of reflection is a diagonal line. It may look hard, but all you need to do is swap the x and y coordinates for each point. Sometimes, a problem may declare the line of reflection is on a number, like y equals 3. Don't get this confused with the y-axis, because y equals 3 passes through y3. Now, there are two methods you can use to find the reflection of point A. The first one is to count the distance between the point and the line of reflection, and then multiply the distance by 2 and add it to the y value, because y equals 3 doesn't move the x position. The second method is a formula I made myself after not being able to find the alternative method to counting. The formula goes like this. Line of reflection, or L, equals y or x plus d, aka distance. From there you can multiply d by 2 and add d to y, and that is the point's reflection. Here's the proof. A equals 5x minus 4y is given. L equals x plus d is the formula. 2 equals 5 plus d is substituting the numbers we know into the formula. Subtract by 5 on each side to leave d by itself. Multiply negative 3 by 2 because a reflection is twice the distance away from the starting point and the line of reflection. Add the x. Negative 1x is the x-coordinate for A prime. Next are rotations. Rotations are a figure's circular motion around a fixed point. Here I will place a point on negative 3x, negative 2y. Here we will assume every rotation is counterclockwise to avoid confusion. Here's a simple problem. Rotate point A 90 degrees about the origin. To find the image, you simply need to swap the x and y of your point and swap the new x's symbol. If you keep doing this, you'll be able to map out 180 degrees, 270 degrees, and 360 degrees. Sometimes the rotation point won't be on the origin, but on a different coordinate. For this demonstration, you'll have to rotate 90 degrees around negative 1x, negative 1y. The way you find the A prime here is quite interesting. You need to translate the point so that the point of rotation is on the origin. Here, you need to add 1 to both points on both coordinates. Now you can rotate like you would about the origin, and then you subtract 1 from both points on both coordinates to translate them back. 0x, negative 3y is A prime. Next up are dilations. Dilations are a type of transformation that make a figure smaller or larger using a scale factor. Here I will place a triangle on this graph. Point A is on 3x 2y, point B is on negative 1x, negative 2y, and point C is on negative 3x 3y. Here is a problem. Dilate the figure, ABC, using the scale factor of 2. To get the answer, you simply need to multiply by whatever the scale factor is. For this problem, multiply all points by 2, and you get your image. One thing to take note of is that this is an enlargement because the scale factor is higher than 1. If the scale factor was smaller than 1, it would be a reduction. Sometimes you may have the preimage and image, but need to find the scale factor. For this problem, simply take a point and its prime and then divide them to get the scale factor. Thank you for watching. I hope you learned something new and have a nice day.